This conference will now be recorded.
Okay, guys, are you able to see my screen?
Yes.
Okay, great. So this is where we are. Let's do a quick recap before we actually, dive into what we basically need to do today. So we have a developer who's developing his code on a local machine, and we have something like a Git repository. So you have a developer who's like working on his local machine, and you have something called as a Git repository, which is in our case Azure repos. So a remote repository out there that is sitting in a cloud called Azure DevOps, just dev.azure.com, just dev.azure.com out here. And this developer out here wants to now push all his changes, meaning he's like worked on a lot, he's cloned the repository and he's done a lot, and he wants to push changes basically into a branch. And here we have something called as different branches out here, like main branch or a master branch, and we have a develop branch where our developmental activities are primarily taking place from. And for the developer to, let's say, go ahead and commit any changes onto this particular branch out here, let me increase the screen. Okay, for my developer to do any kind of changes out here, I am making sure that the developer uses something called as a feature request. Like the develop branch is protected. I am not allowing my developer to do a direct commit, and the develop branch has a policy something like this, that what, I require at least a minimum one reviewer to approve this out. I will check for comment resolutions and all that stuff. So the branching policies are in place even before the developer raises a pull request. All these things should be basically ticked off. So the developer is not allowed to make a direct commit onto the branch. So that's the reason the developer will approach using something called as a feature branch. And we have seen how do you create a feature branch even from your local machine, and how do you make sure to push this particular feature branch to the remote repository, and how do you raise a pull request between the feature and the develop branch. So we are approaching using a feature in the develop branch, and once the code is inside the develop branch is where I am triggering something known as a continuous integration pipeline, a CI pipeline in short. I am triggering something known as a CI pipeline out here, and we have discussed what are the components that actually go into a CI pipeline. And very importantly, I am triggering a CI pipeline on something known as an Azure hosted agent or a Microsoft hosted agent. And we said that the agent specification is that the agent is a Windows 2016 server, on top of which we have a Visual Studio of a 2017 version installed, and it's like giving it to you. And we have included something known as a continuous integration trigger. So whenever your develop branch basically is updated, this particular trigger will basically take the code and convert it into something called as a binary. And at the end of the CI pipeline, as we seen yesterday, you will have something called as an artifact that is coming into picture. You will have something known as an artifact that is coming into picture, which is nothing but raw binaries and etc., which you will be later using in something known as a release pipeline. But one quick question here is that this is good, like this procedure and all is good. Like you can say, Kiran, yes, this is good, you have like made good amount of changes here, you have protected your branch and everything, but I have a complaint from the lead telling that you have protected this branch good, you require a reviewer to, let's say, review the entire code. But when some developer is like doing this, when some developer is doing a feature, let's say 200 branch, from, let's say, he's pulling this from the develop branch out here because he wants to do his own changes, and he came up with, let's say, like he went ahead with, let's say, the .NET Core project. This is where he wants to do changes, and let's imagine for now I am doing a change in the readme file, and I am doing like about hundreds of changes, not one line of code but thousands of lines of code. and not one developer, but 100 developers. So imagine, will it be logical enough for asking my lead to check all the code that all the commits or all the files basically that are coming as a part of this particular pull request? Yes, it is true that I have, like, let's say for example, if I do a pull request right now and I give it to my lead telling that, okay, fine, this is a pull request, please go ahead and check this out. Now the lead will come here and I'll say, okay, fine, there are like thousands of files, fine, which is good. But will you, or do you think that if, let's say, this is a manual check, will it be efficient enough? Of course not, right? Because again, if it's a manual check and if, let's say, one person has to review so many lines of code each and every day for each and every developer, then it might not be always that the code quality is achieved. It might not be always the case that the code quality is achieved. Meaning, the developer will just, I'm sorry, the lead will just come here and say, okay, fine, this is the code that is coming into picture. Okay, fine. I'll just do a quick review because even I do not have time. I'm like working on a lot of things. I'll say approve. I'll say set to complete this out and delete the branch. Now you have taken the same code, like you basically have taken the same develop branch. You have built that code. You are also taking that code basically into the environment, into the Azure environment, and then you find issues there because the code was not properly checked. Now again, if I backtrack and do a reverse engineering and see where the point of failure is, it is this, that whenever there is a pull request that is getting into picture, and they're not one pull requests, believe me, there are like about hundreds of pull requests every day by the developers. If your organization is big and it grows more bigger, there are the number of pull requests basically per day kind of increase out. So how can I eliminate a human effort out here? Can I have an automated gate here? Can I have an automated gate that can check what is the code that is coming into picture and then give me a proper analysis of the code, and then basically only allow me to go ahead and approve the pull request? Can I have something like that? That is where you have a concept called static code analyzer, static code analysis or analyzer, which is an automated way in order to test your code, which is an automated way to see what is the code quality that is coming into picture, to see what is, let's say, the code quality that is actually coming into your branch. And there are different tools out there for automated testing, and some of the tools are like Sonar, JCuckoo, Gradle, Datadog. There are a lot of things basically out there in the market that which you can leverage to achieve this particular process out here. But what we are going to look at is something called as Sonar, one of the most popular tool, one of the most popular tool that basically is available out there for static code analysis. So you have Sonar, White Source, Fortify, Gradle, Datadog, a lot of things basically that are available in the market, out of which we will using or something known as a Sonar, which is like a very, very, very popular tool. Like in most of the organizations where I basically have worked, we have looked at Sonar as a tool, or we have used Sonar as a tool for static code analysis. Then how do I leverage it? Now I will create a build pipeline for the entire process, and I will call this as a validation build. Okay, what I'll do is, like, I'll just clone the entire pipeline. Like, this is the pipeline basically that I'm interested into because I am basically analyzing, let's say, something like a .NET Full Framework project. So what I'm going to do is, I'm not going to create a new pipeline as such, but I will rather use the existing pipeline. So I'll come into the .NET, let's say the Full Framework project out here. This is the full framework pipeline which is working fine. So I'll go into this particular pipeline, click on more actions, and I'll say clone. So I am creating a replica of the same pipeline out here, and I'm saying this is a full framework validator, or a validation pipeline, or a PR check pipeline, or a PR check build, whatever you call it. It's nothing but a validator out there. What I now want to do inside this validator is this procedure is okay. All these are, .NET installation and all that is fine. But I want to make sure that as and when someone builds this particular solution, I need an analysis on that particular solution out there. So what I'm going to do here is I'm going to add a job and say Sonar, and I have something called as Sonar Cloud out here. Now you might not see the same thing. You might see something like get it free, like the plugins or the tools basically that you have are nothing but extensions. So what you need to do is like just click on get it free, and there will be a different portal that gets opened. So if I say get it free, there'll be a different portal that is open out here. Just click on get it free out here. Like all these tools are free, you no need to pay anything for this. And once this is done, it will say okay fine, do you want to install this extension, and it will ask you which organization it is. So I'll just say install. That's it. This is the procedure that you need to do for Sonar. For me, I already have Sonar out here, so that's the reason it's showing me add. So what I'll do is that I'll add two steps out here. So for you guys, it'll be something like get it free. So just click on get it free, go into this extension, click on install, and after refreshing a couple of times, you will now find an option to add. So what I'll do right now is I'll do two things out here. Firstly, I'll prepare the Sonar for analysis. So I'll say add this step, and this step should always come before the code is built. There is a procedure that we need to follow out here. So I'll say okay fine, I'll just put it somewhere out here, which is just to prepare my Sonar cloud, which is just to prepare my Sonar tool to analyze my code. And I'm talking about something called a Sonar, and the Sonar itself is a different portal. If you just type in Sonar cloud, you will have a different portal for Sonar as such, which will say okay fine, welcome to Sonar, how do you want to sign in? I'll say login, and I'll say login using with Azure DevOps, because I've already signed in with Azure DevOps. So I'll say login with Azure DevOps, and I'll just give the account basically that I'm basically using right now. And this is like protected with MFA, so I'll just have to send a notification, and someone who's using this account should approve it. Just a second. So let's get this approved. I'll say yes, fine, not a problem, sign. So I'm just logging into Sonar using Azure DevOps account, and I'll say yes. Now it says great. This is how the first portal really looks like for Sonar. Like this is altogether a different portal. This is altogether a different project. I mean, this is altogether a different third-party tool as such. Nothing to do with Azure. You can also basically include your Sonar in like AWS projects and a lot of things out there. So it's a third-party tool basically that I'm going ahead and let's say using it in order to analyze my code. And this is the first page that I see. And out here I'll say create project manually. Don't do an import with organization. I'll say create projects manually. And now it's asking me to give a key, meaning it's just asking me to create something called as an organization in Sonar that can be used to analyze my projects. I'll say this is my test analysis something like this until I get a unique name. I'll say continue. Now it says, what kind of a plan do you want? Do you want a free plan? Do you want a paid? In paid, you have like a lot of like options and etc. But I'll say I'll go for a free plan. I'll say create an organization. Now it's okay, fine. It says, okay, fine. You have created a space for yourself where you can analyze your projects, which is great. Now, could you tell me or could you give me a project key? So I'll just say this is a test key 123. So I'm giving something called as a project key out here. And even the project display name is like something like this, test key 123. Now, in order to make sure that I make some sense, what I'll do is like I'll just give the key or I'll just basically give the name of my repository as the key. I'll say test repo hyphen net full framework in order to differentiate between a lot of things. I'll make sure to put the same thing out here. So it is what's that? Let's see. Test repo hyphen net full framework. So I'll take the same thing and I'll say test repo hyphen repo hyphen net full framework. So whatever you can give it here, that will become the key and the display name of the project that you're going to analyze. So I'd like to keep it the same way as my repository to make sure that I'm analyzing the projects that are coming into this particular repository. So I'm saying, okay, fine, just give the key of this particular project and make this as a public because private is not an option when you go for a free trial or when you go for a free account out here. And I'll say setup. As in when I do a setup out here, I'm like good with this. Now what I need to do is just a few things out here. I'll come into something called as administration and I'll go into something known as branches and pull request. And I'll say master is not my main branch because all my code is basically getting built out of something called as develop. So I'll say rename branch and I'll say develop is the branch that you need to analyze. I'll say rename. These are the things that I am doing on the Sonar side of things. Now coming to Azure DevOps, Azure DevOps now needs to understand how you are integrating your project with Sonar, or rather how you are basically connecting your project to Sonar. Meaning Azure DevOps is again a different service, guys. ADO or Azure DevOps is again a different service out here, and Sonar is a different service. So you have Azure DevOps that is sitting out here, and Azure DevOps now wants to connect with an external portal called Sonar. And Sonar is again a different third-party software which has its own, which has its own security built in and all that stuff. Now, how do you think will Azure DevOps connect to Sonar and authenticate itself? Because you need something called as an authentication out here. And all the third-party connections, everything is a third-party connection in Azure DevOps is maintained in the form of service connection. Service connection out here is maintained in the form of what? Service connection. Between, meaning I am now trying to establish a service connection between Azure DevOps and Sonar portal so that my projects can be analyzed. So what I'll do here is that I'll come here and I'll say I don't have a service connection as of now. It's saying, you know what, give me Sonar Cloud endpoint. I don't have one now. I'll say create. Now it says, can you give me a token from Sonar Cloud? Why is this token required? So that Azure DevOps can authenticate itself with the Sonar portal because Sonar needs some kind of an authentication to happen. So what I'll do is that I need to generate a token from my Sonar. So I'll say come to the account. It'll give the name of the account out here. I'll say my account and now I'll say okay fine. Going into the security, I'll say generate a new token. I'll say this is Azure DevOps integration. And I'll say generate. I'll copy this token out here that got generated from, let's say, Sonar. Go into the Azure DevOps, put the token in and say verify. As in when I do it, it says verification was successful. So again, I came into my account and I said my account, security, enter the token name and said generate. As in when I generate it, you will have a token out there, which is a alphanumeric string. Copy it out and I paste it out here. And it's asking me, it's asking me what is the name of the service connection that you want to give. I said this is a Sonar test service connection, something like this, service connection. And I'll say verify and save. As in when I do a verify and save, right? It's now asking me, can you tell me what is the organization in Sonar that you want me to basically send all this report to? Or how do you want me to analyze? And I have something like my test analysis or something like that. If I click this, the same project gets reflected out here, or the same organization gets reflected out here, because you have a valid token that you provided to Azure DevOps. So Azure DevOps now can look into Sonar. And now it's asking you, what is the project key and the project name? Right? This is something that we have created out here. You set my projects, and this is the name of your project. This is the name of one of the projects basically that I'm like kind of working on. And here you will have the key. The key is usually the same as the display name. So I'm taking this as a key. I'm entering this as a key. Sorry, not this one. I'm entering this as a key and I'm entering this as a project name, because now it makes sense that I am testing out my repository using the same key and the same name out here. Using the same key and the same name out here, I am testing my repository out here. And this is all the connection that I need to establish. So I've created a service connection. And for creating a service connection, I wanted something called as a Sonar token. So I went into my Sonar account, into the security of the Sonar account, and generated a token out there. And gave this token to Azure DevOps so that Azure DevOps can now look into the Sonar. So this is just the preparation of the Sonar Analyzer. That's it. I have not run the Sonar yet. So what I want to do right now is that I'll say add. Now I'll say Sonar and I'll say run analysis. And the code analyzer should always run after the solution is built. Before the solution is built, if you run the code analyzer, it will not be able to analyze what's there. Code analyzers want the code to be first converted and then they do a test. And finally, I'll say after the analysis is run, publish the quality gate result. Meaning whatever results that you basically have like got, please publish this out. Like all I want you to do is publish it out here. And this is a validation, guys. Okay, I'm just doing a validation. I don't want to produce my artifact. I don't want any artifact to be produced out of this, because all I'm doing is a validation. So I'll just remove this task. So this build right now is a validator and not a producer of, let's say, an artifact. All it does is validates my code that is coming in. It validates whatever code that is coming in as a pull request to or on the develop branch. So what I'll do right now is I'll say, okay, fine, save this out. I won't run this out right now. I'll say full framework validator. I'll just save this out. Now what I'm going to do is that I'll go into my branches and I want that particular validator to validate the code when someone raises a pull request to the develop branch. That's what I want to do, right? Because I want to do an automatic analysis of the code. I'll go into the branch policies and I'll include another branch policy which called build validation, which says validate code by pre-merging and doing something like this. I'll say yes, I want to add it, and now I'll say it's the build validator, which is the, let's say, the pipeline basically that I'm looking at. Let's see, is that the one? Let's see something else. Let's see. I had a couple of build validators out there, so I just want to check that it's the right one that I'm looking at. Okay, so this is called as a full framework validator. So that's something else. So this is the pipeline basically that I'm actually looking at. So I'll say add this. I'll say full framework validator is a pipeline that I'm looking at, and every other setting is okay for me. And I'll say validator, just a display name out here. And I'll say save. Now what am I doing is that I've included that pipeline as a part of my branching policy. I've included that particular validator pipeline as a part of my branching policy. Now what happens is that if a developer now comes in with a pull request, and if a developer, let's say, does a new branch out here, let's say feature hyphen 300 from the develop branch, and now if I go ahead into the feature branch, and if I now basically edit my feature branch, like the readme.md file again, I'll say this is a test validation. I'll say commit. Now I'll create a pull request to the develop branch, and I will say create. As in when I create a PR, do you now see that there are two things? One, I need a reviewer, I need an approver, which is great. The other thing is a validator that got queued. I did not do this at all. I did not touch this pipeline at all, the full framework pipeline at all. But as in when I raised a pull request, it automatically got queued because my branching policy triggers this pipeline whenever there is a pull request. And this particular pipeline will now go ahead into the PR or into the feature branch and analyze all the code into it using something known as a sonar. So it will now check whether you know what I have everything and all that stuff. And now it will do a .NET restore, build the solution out, run a code analyzer, and publish the quality gate result. And if the configuration was successful, and if let's say the code build was successful, the analyzer will run successfully out. Let's say if the code build has issues, has bugs with it, the analyzer will identify that there are bugs and the analyzer will fail. Now see, the analyzer is running and the analyzer is scanning for everything out. It's scanning, it is doing all the scanner, it's trying to analyze everything and it is trying to publish a result out there. This is what the analyzer is now trying to do. And this is an automated check. I do not want to go with a manual approach because the develop branch is something which is important for me, is something which is important for my code development to happen. So I do not want to take a chance out here. So that's the reason I am now relying upon an external portal like Sonar, which will now give me an idea on what the code quality really is. And all the analyzer does here is that it will now start testing. It will now do a lot of basically tests out there. It will do a full integration test out there. And then if the incoming code is okay, the analyzer will say, okay, fine, there are these many test cases that I've kind of run, and these are the number of test cases that actually passed, and these are the number of test cases that actually failed, and I'm okay with it. And now I'll go ahead and publish something called as a quality result. See, it's now saying, okay, fine, this is the number of, basically, it's like, fine, this is the number of, let's say, the code that is analyzed and all. See, for example, it says here that, what, 9 are the source files. There are like 9 source files basically. So I have analyzed all the source files. And after the source files are analyzed, I will go ahead and, let's say, upload the result. So the analyzer will take about 2 or 3 minutes in order to run. And what this analyzer is going to do out here is that this analyzer will analyze each and everything of your project automatically. Now you do not have to actually go ahead and have a human check out here. Meaning you still need an approval, you still need, let's say, someone to approve it. But that approver is not now concerned about what is the code quality, because the Sonar Analyzer is already giving him the code quality out here. The Sonar Analyzer is already, let's say, giving a code quality out here. And it says, what? Here, if you see at line number 231, it says analysis is successful. You can now find the result at something like this. It says fine, analyzer is like, kind of successful. If I, scroll all the way down, it says I have published all the results in this particular page, in this particular Sonar portal out here. If you go to the Sonar portal out here, if I go to my projects out here, it says the default develop branch is not analyzed, because you'll have to first run an analyzer on the develop branch. But if you, let's say, come here and let's say look at this one out. Now you see, this is how your analyzer will actually look like. That it says, okay, fine, the analyzer is passed, and it will also give you what are the issues with your branch and etc. And see, it's like for merge into the develop from feature 300. From feature 300, you are actually basically merging it out, and it says, okay, fine, if there are any issues, if there are any measures that you need to take, if there is anything basically that you need to basically have and all that stuff, and also show you if there are any issues. It will also show you which line of your code has the issue, so that you can fix it. So it basically gives you all the results like this, telling that the overall is passed, there are zero bugs and etc. Because this is the bare minimum code that we have written. And if it's an actual code, it will give you what are the bugs, what are the vulnerabilities and all that stuff, based on which you can take a call whether to merge this or not. This is how I'm making sure to have an automated gate out here. And only if this passes, like now if I go to my PR, only if this passes will I be able to, or where's my PR? Let's see, fine, where is the pull request? Yeah, this one. Only if this passes will I be able to go ahead and merge. So these are the checks. So analyzer passed, which is great. And someone must approve it. So I have approved it myself. And now since I got the approval, I can now go ahead and complete my merge and delete the feature branch. This is how I integrate something known as an analyzer out here in the form of something known as a sonar. Very, very popular interview question is that what kind of analyzer that you did use, and how did you integrate, where did you integrate it? And scenario based questions are something like, I have a couple of developers who are trying to commit code using a pull request onto the develop branch. I don't want a manual check. Can you give me an automated option? And analyzers work in the same way. Whether it being Sonar or Fortify, the settings are almost the same. Like you need an organization, a project key, and etc. to get integrated with, and all that stuff. And this is how I've integrated my analyzer. So my analyzer is now running from a different pipeline, which is called full framework analyzer, that is sitting on top here. And I've taken this particular pipeline, integrated it with my branches into my branching policy. So into my branching policy is where I've added this something known as an analyzer. And I said this is a required check. And I said this is a required check to see whether the code is good or not, and give a proper picture on what is the, let's see the code quality. And now it says, what, this is the pull request that actually triggered me. And for merge into develop from feature 300, this is the result. This is all the result that you can check. And it says, okay, fine, these are the number of duplications that I found and all that stuff. But it says there are no bugs and etc. If there are any bugs, the code will fail. there were any bugs and all, the code will actually fail out. So this is the concept of a static code analyzer, guys. So any questions here, anything that you did not understand, because this is a very, very important concept. So if there is something that you weren't able to follow, please let me know. I'll clear that out.
Yeah, Kiran. So if I'm understanding correctly, so when
Mhm,
the developer sent for the PR for approval,
mhm, mhm.
so before approval, this pipeline will be run and give the an analyzer report
Yes,
to the
exactly.
approver.
Correct. So what will happen is that, Chandra, is that here, if you look at my pull request out here, there are a couple of checks that are there. So all these checks must be satisfied. Even if the approver goes ahead and gives the approval, even if let's say the approver goes ahead and gives the approval, I still want the sonar to complete. So if the sonar is not complete, your pull request will never be merged. But generally what happens is that when the approver is trying to approve it out, he will wait for the sonar to complete, take the analysis report, go into the sonar portal and sees what is this and etc. If he thinks it's okay, he'll go ahead and give the approval. So yes, this is this is an automated code analyzer or a static code analyzer is what we can say, which will go ahead and give you an analysis report on how things are working out there. So yes, your understanding is correct.
Okay. And this automated analyzer or
Mhm.
Sonar, how it will know which code it needs to validate, whether it's JSP or ESP, .NET or framework core.
So what happens, Sanjay, is that analyzers can analyze any kind of a code. Like it doesn't really require it to be a specific language. You can also give a Java, you can also give a C sharp. So all this is embedded within the analyzer. Now, if you see, add the prepare for analyzer and run the analysis step out here, which ran out. Let's see. I don't know why this is like running again. Fine. Now, if you see this particular step of analyzing out here, it's going into the file and it's firstly downloading all the plugins it needs. So it's saying, you know what, load the plugin and all that stuff based upon the language. And now it says, okay, fine, I found an active CI and all that stuff. And it went ahead and basically it said, okay, fine, these are the things. And see, it identified that this is a C sharp family. And it downloaded all the plugins, like whatever it needed, like C sharp, Java, everything it needed. And then it's trying to run an analysis. So analyzers are really very intelligent, like they're like intelligent machines built out. So you can use the same pipeline to analyze a .NET Core project. You can build the same thing to analyze, let's say, a .NET Full Framework, a C Sharp, a Visual Basic, Java, and probably let's say Python. I'm not really sure if let's say Python is also supported by Sonar. I have not gone through the Sonar documentation in a while, so I'm not really sure if they're supporting Sonar. But available languages out there are like Java, .NET Core, Full Framework, C Sharp, Visual Basics, and all that stuff is actually supported by them. So it installs all the plugins by default and it runs all the plugins on the code. So it doesn't really need, say now it says, you know what, sensor is like, .NET. It's now sensing that, yes, this is .NET and then I need to analyze a .NET project. If it is Java, it will basically load a different plugin and then run it on, let's say, run it, let's say, on your code. This is how generally it kind of works out.
Okay. And do we get timeline how much time it would take to compare? Means if we are releasing some build, so it will
Mhm.
take some time, right? Approximate
Right.
how much time can we calculate?
Like for the analyzer to run.
Yes.
So the analyzer again depends upon the code. My code has like, literally my code is just a boilerplate. So I just took a very simple code and ran an analysis on top of it. So it took about 3 minutes. But sometimes I have also seen this analyzer to run for about like 15 to 20 minutes also. So it depends upon the number of code that you're giving, the number of files it needs to analyze, and how many files you're actually targeting in your analyzer and all that stuff. So minimum, let's say about 2 minutes, and maximum, let's say about 20 minutes or so. That's
Okay.
the. Mhm.
That means not more than 1 hour. Like if someone gives some project to
Mhm.
check it, so we need to
Mhm.
give timeline, right? How when we can provide.
Exactly. So not more than 1 hour, certainly not more than 1 hour, but there were days I've seen this analyzer running for 1.5 hour also. Because at that particular given day, the sonar was down. So there were some migrations happening on sonar and etc. So that was down. So I've also seen that happen. So it all depends upon, let's say, that particular given day, whether the sonar is up and running, whether it's good or healthy and all that stuff. It depends upon that. But in 99% of the scenarios, not more than 20 minutes for the analyzer to run.
Okay. And last question, this it will
Mhm.
compare, right? Bugs means
Mhm.
it's kind of some syntax error or anything else it will check.
So it will also check for syntaxing. Yes, it will basically check. I mean, bugs is generally syntax errors. Like it's generally syntax errors out there. Now it also analyzed my develop branch also. Like it ran for the second time and analyzed that. I probably had saved that out there also. So see, these are all the bugs it's trying to say. Unexpected duplicate border color, all the syntax errors basically. It's trying to give out here, telling that what this might be a bug in future. Do you want to basically resolve it right now? And say what, there is an unexpected function call, and it's also telling me which line of my code is actually issue with here and all that stuff. So all these are, let's say, the bugs according to what Sonar has. So if the code, let's say, see, if let's say this is a develop branch analysis and it gave me a complete analysis of whatever was there, and it said okay fine, these are the vulnerabilities and all that stuff, and this will give, let's say, an approver a freedom to see whether he needs to approve it or not. So all this is something that gets covered.
And will it give suggestion also? Like
On a free trail, like right now I'm using a free account, so it will not give a suggestion out there. But let's say if you're using a licensed version of Sonar, then it'll also tell you what is the suggestion and etc., what needs to be done and all that stuff.
okay, thank you.
Yeah. Anything else, guys?
And in all scenarios, we should run the Sonar.
Yes. If you're approaching using a pull request, and if you want to merge your pull request, let's say, into a branch, there is a very high suggestion that you run some kind of an analyzer, like either Sonar, Fortify, White Source, Gradle, Datadog, whatever it is. Either some kind of an analyzer that you need to run on your code to understand what is it. Because this is the only place where I see that can corrupt my repository. Because here the developer can come with any code, they can test it in local, but it might not work in the repository. Once it's there in the repository, it might not work there. So this is the point where I see to have a manual intervention in order to, let's say, erase that manual intervention, or in order to, let's say, eliminate that manual intervention. I want to basically come with an analyzer out there. So yes, highly recommended to go with an analysis as such. Does that answer your question, Akila?
Yeah, yes. So in order to approve by the team leader, we can run the Sonar, right?
Yes. And this is how you integrate Sonar into your builds. So I've integrated Sonar into my build, and I made sure that what, the Sonar always runs when a pull request is actually coming into picture, and the Sonar will analyze all the code before you can actually take a call whether to merge this pull request or not. Is this fine, guys?
And could you please show the error that yesterday we
Hmm?
got right in the pipeline? One error
Oh,
we
that one?
got. Yeah,
Sure. So,
I also got same error.
mhm. On the publish step, is it?
Yes.
This one, right? Are you getting like the same error out here, like
Yeah,
the
yes.
one that I
Exit
got out
code
of
one.
exit code one, and you are getting something like uh, this one? Like this is
Yes.
the actual error out here. So what you do is just, what I did like is that on the publish step, don't publish it as a web project. Like if you're publishing it as a web project, it is looking for that particular file. And if you take this out, it's not looking for that file. So just disable this out. Don't publish this as a web project, and you don't have to disable anything else out else there. And once you disable this out, it's kind of running out. And also use, for your agent, use Windows 2019 server. Don't use a 16 because that isn't supporting the published task out there so well that 2019 kind of supports. These are the two changes that I've actually brought in.
So
Okay, Akila?
again we should run. Yeah. By applying this
Yeah,
again we should.
yes, you'll have to run this again. You'll have to take, I mean, you'll have to uncheck this and change it to your Windows 2019 agent and then run it out.
Thank you.
Yeah. Any questions? Anything else, guys? Anything else basically on this one? Now, one quick thing out here is that this particular prepare Sonar analysis step, right? Now it has a lot of things out here like project key, project name, all these which are a bit sensitive information which I don't want to expose. Because project key again is a very sensitive information which I don't want to really expose it on the pipeline, and generally developers also will have access to the pipeline and they can actually check what is there inside it. So I don't want to give it in this way. Rather, I want to take this and I want to declare this particular parameter as a variable on my pipeline, which brings me to a very important concept called variables. Variables are something that you can actually declare out here. For example, I will declare a variable called sonar key, and I will give the variable the property and I will log this out. Now only an administrator, even if I let's say unlock this out right now, I'll be able to see it. But if someone unlocks it out other than me, they will not be able to see a key out here. So I'm locking it out, and this is the variable that I'm using called sonar key. And what I'm going to do right now is instead of referring the direct parameter out here, I will call the variable, or instead of referring the direct hard coding the direct value out here, I will call the variable called sonar key. How will I call it? Dollar open parenthesis close parenthesis name of the variable. This is how you can call variables that you have declared on the pipeline. And other thing out here is that project name is also, I want to also variabilize this one out. So I'll say this is project name. I'll have a name to my project, not a sensitive information, it's okay. I'll take this particular variable and I will also do something like dollar and then save it. And one very important thing, guys, whenever you save it, please mention a comment. Now, these are a couple of tips to just tell you that you have actually worked in a real-time environment. Because when you're saving it and not giving a comment, it becomes very difficult to track the history of what you have done. So while you're saving it, now I have given a parameter, right? So I'll say parameterized sonar project name and project key. I'll say save. So whenever someone comes and looks into the history of this particular pipeline, there will be this particular history and they can understand, okay, fine, this is what they have done. So please make sure that whatever you're saving it, whatever you're doing it, add a comment to it so that it will have a history along with the timestamp along with it. So please have a comment out there and please try out this something called as a variable and use this section called variable in order to declare all these stuff out here. Okay. Now there is one more concept that I wanted to cover which is called self-hosted agent, but it needs some time, it needs some respect. So I won't cover it right now. So I will take questions now. And if there are any specific questions regarding to the interviews and how to prepare, what are the interview questions, please do ask me. I'll let you all know how to prepare it and let you all know what we need to do and all that stuff. So I'm open to take questions for the remaining time that we have. Guys, very importantly, please practice the Sonar. Okay, please practice Sonar, and the interview questions that an interviewer can ask from the topics that we have covered till now in Azure DevOps is that, what do you mean by git commit? What do you mean by pull request? What do you mean by git clone? How is it different from git pull? And how is it different from git push? What kind of a branching and merging strategies are followed by a project? What do you mean by branching policies? What is the difference between a continuous integration pipeline with respect to a .NET full framework project versus a .NET core project? What are the steps that you will basically write, or what are the steps that you will basically include inside your project or include inside your pipeline, sorry, now to make sure that the build is successful? What kind of an analyzer have you used? What can you tell me, or how did you configure the analyzer? What are the important things that you need to note while configuring the analyzer? What are the steps basically during the analysis procedure? And what are the best practices that you have followed? These are probably some of the questions basically that can come up while you are giving the interviews. And these are the questions that can arise from the specific topics that we have talked about. But in general, when you talk about Azure DevOps, the important things that can that can really play a major role in the interview is that, firstly, build pipelines, yes. Very importantly, release pipelines. And in release pipelines, have you used something called infrastructure as a code? Meaning, have you deployed infrastructure using release pipelines, and what kind of a technology that did you use? Whether did you use a Terraform, use an ARM template, use PowerShell? What is it that you used? And what is the strategy that you follow for your release pipeline and all that stuff? That is something that we will see once we get into release pipeline and all that stuff. And very importantly, what do you mean by an agent in Azure DevOps? What is the difference between a self-hosted and a hosted agent? What kind of an agent did you use in your project? Now, one thing that please remember is that when you are coming from a real-time environment, most of the projects out there use self-hosted agents only. Hosted agent, which is a private agent by Azure, or basically which is an agent provided by Azure, is very rarely used because it Azure only gives you like one or two agents to be used, and they're like very slow for your build procedures and etc. So please tell that you have used something known as a self-hosted agent. Then the next question will be, how did you configure your self-hosted agent? Can you tell me what are the steps that are involved in the configuration of a self-hosted agent? How do you do that? All these are the questions that can come up during the interview. And something known as variables that we have seen today. That what do you mean by an Azure DevOps variable and all that stuff, which we'll be analyzing, and we'll be seeing how do you use that variables and all that stuff in let's say the coming classes. We'll be discussing more on variables. We'll be discussing more on those classes out there, or on those topics out there. So these are the things that might probably come. Let's say when you are giving an interview, these are the things that can probably come up, guys. So any questions on this? Anything in general, anything in specific, anything that you're facing an issue with?
And also, can we run the run the Sonar on the ASP.NET?
Yes. I mean, you're taking the .NET full .NET Core.
Yes, yesterday we created right pipeline.
Yes. You can run it on the same as well. Like there is no issue. You can run it on the same as well.
So, hosted agent means we need to build the VM virtual machine with the operating system like Windows 2016 or 19, and we need to install the Visual Code on that.
Hosted machine means something that Azure is giving you. Self-hosted or a private agent means you need to basically build your infrastructure, install Visual Studio on that, install all the softwares that are required, and then add it as an agent in the Azure DevOps. So it's hosted versus self-hosted.
In the self-hosted, how can we specify here? So here we can agent specification. They are giving the Visual Studio 2017 and 2016. So how can we
Right.
mention our self-hosted one?
So in self-hosted, what you do, Chandra, is that you install 2019 out there. Like you install whatever is the latest and you use that in your pipeline. So in here, you are not going to, let's say, ask for a specification. Rather, you are going to, let's say, decide a specification for the agent. Like you can have both 2017 and 2019 Visual Studios also installed on the same machine. Not going to harm anything. So you don't have to really specify that, you know what, I need this particular agent. For example, I have a self-hosted agent with me. And if I want to use that agent, all I'll say is that I'm not specifying anything. I'll say use this agent from this particular pool. That's it. I'm just saying use this particular agent from this particular pool. And I'll just save this out. That's it. So I'm not defining any specification out here. And if you go into the project setting out here, into something known as an agent pool, you'll have Azure Pipeline default, and I have created this one pool which has an agent out here, which is my on-premises agent. Meaning what I have done is that instead of, let's say, spinning up a virtual machine in Azure portal, which will actually cost me, I have used my local laptop as an agent. I've used one drive in my local laptop for the agent. I've installed my agent here. So I am calling this as an on-premise agent. So the question, yes, you can definitely use on-premises hosted machines as also agent out here. Like for example, this is the work folder where the agent is actually working on my machine, and it's like downloading everything and all that stuff. So if you look at this, the last run was something like this. Like I did some copy and all that stuff activity where it went ahead and it, basically downloaded all the code and it's doing a lot of stuff out here. So I have basically made my local machine as an agent and I'm calling it as an on-premises agent so that I don't incur cost with Azure DevOps. Like, I mean, sorry, when, to spin up a virtual machine in Azure and etc. But in real time, since the projects are, let's say, very matured out there, they will create a lot of virtual machines in Azure and use them as an agent.
So
So, hmm,
making our laptop as an agent, we need to install
hmm,
any agent installation or any plugins on our
yes, you
laptop.
need agent installation. We will see how do you install agent and all that stuff. So you need an agent installation done on your laptop. For example, in my laptop, the agent is like kind of running as a service. So I've installed it. I've installed it like a while ago. And if you go into the services, you will see something known as an Azure pipeline agent that is running in the background. Let me see if I am able to show that to you. I'm not sure where I found that. Okay. It'll be called something VSTS agent or something like that, or something like an Azure DevOps pipeline agent or something like that. But it's kind of running right now in my backend because I know this is for a sure, for a fact that it's like kind of running as a service on my machine. So yes, you'll have to install the agent on your machine. For example, is agent activation runtime and all that stuff that is running. This one, it says my Azure DevOps Playground on premise. That's the agent basically that is running in the background. This is an Azure pipeline agent, and I've installed this agent as a service on my machine. We'll discuss about that in the tomorrow's class on how do you install the agent, how do you make something a self-hosted machine and all that stuff. But since to avoid cost, I basically turn my local machine into an agent. So that is something that you can also do. But when you're turning your local machine into an agent, make sure that your local machine has Visual Studio installed on it, .NET SDK installed on it, all that stuff that you need for the code to be built. Otherwise, your code build will fail. So even if for a virtual machine, we'll do the same thing. We'll install all the required softwares in that, and then convert the virtual machine into a build machine, into an agent, or into, let's say, a self-hosted agent on Azure DevOps. So how do you do it and all that stuff? We'll be looking into that. So when you give an on-premise pool, meaning when you give your own pool, if you use an Azure pipeline pool, then it'll ask for a specification because you now need to tell Azure what kind of a specification you need to provide. For which I am basically giving a specification on all that stuff. But when you do it from your own machine, or when you basically do it on your own private agents, you don't need to give a specification because you are the one who's deciding on the specifications right now. So that becomes a very big difference between a self-hosted and a hosted agent. And you can have multiple self-hosted agents running on a same machine, like about 7 to 8 agents running on the same machine as such. So you can do that also. Does that answer your question, Chandra?
Yes, yes. Thanks.
So we'll look into the concept very detail on how do you create a self-hosted agent, because that becomes a very important part on how do you authenticate the agent and all that stuff. So I'll be creating a virtual machine tomorrow with a specification like Windows Server 2016 or 19, and I'll keep these required software installed like Visual Studio, .NET, and all that stuff, and then we'll go ahead and install the agent on that particular machine. Like if you want a practical demo on how am I doing it, like to installation also, I'll install it directly in the class so that you can follow the same thing out there, because that installation becomes very important to understand what are the software that are required and all that stuff. So I'll do it even directly on the class, even if it takes some time, it's okay. We'll go ahead and do it in the class so that everyone knows how to install the agent, how to use them and all that stuff. Any further questions, guys, for today before we close?
And when we're working on Azure DevOps, we will navigate to Azure also, or only we work in this project?
On Azure DevOps?
Yes.
So again, it depends upon the cloud that you're implementing this practice on. In my case, I have used AWS to implement practices using Azure DevOps or Jenkins also. So I was frequently visiting AWS, and in the project that I'm right now into, we are completely on Azure. So I frequently visit Azure to see what is the state of my infrastructure and what is, let's say, the state of the services there. So I use a combination of both Azure and Azure DevOps. Both are, like, I'll say 50-50% weightage. So you need to have an administrator understanding that. That's the reason we have, like, been covering Azure for all these days. And then you need to have an Azure DevOps background also. So both of them, Agila. It's a combination of both. Any more questions, guys? Anything else?
Hello.
Yeah, Vinash, go ahead.
After we have done with Sonar, how can
Mhm.
we pass this bugs to the developer?
So what you do is, like, generally you initiate the the development team on the same let's say the email thread and etc. And what other thing that you can do is probably automate this out and trigger an automatic email as and when the report is available. So in Sonar, when you especially go for, let's say, a paid account, you can also go ahead and trigger the emails of, let's say, the report to an entire delivery list. So you can also do that using Sonar.
Okay.
Any more questions, guys? Anything else that I can take? Okay, if there are no further questions, then I'm good for the day, and we can meet tomorrow and we can discuss on hosted versus self-hosted agents and how to configure the self-hosted agent and all that stuff. Thank you so much and have a great day ahead, guys.
Thank you.
Thank you.